Now we're going to look at compound inequalities that contain the word or. Solutions will include anything that makes either one or both of them true. So at least one of them has to be true. So let's go ahead and solve this first inequality. I can subtract 5 from both sides, and I get negative 3x is less than or equal to negative 6. Divide both sides by a negative 3. We have to flip the sign because we're dividing by a negative number. X is greater than or equal to 2. Or, on this side, I am going to subtract 8 from both sides and divide by 2. So our solution set is going to contain anything that would make either one of those true. So I'm going to try to quickly number. And I'll graph each of them. So x is greater than or equal to 2. We can include 2, so we get a closed circle. In our red graph, x is less than or equal to 1.5, negative 1.5. We can include negative 1.5 and anything before it. Now, when we were graphing and equations, we wanted the area of overlap. With or equations, we want anything that's been marked at all. So both from negative 1.5 to negative infinity and from 2 to positive infinity are going to be parts of our solution. But how do we write that in interval notation? We'll start with what we know. We know it goes to negative infinity, and it goes up to negative 1.5. It includes negative 1.5, so we do a closed bracket. Then we're going to write a capital U. That U stands for union. It means both this and the thing over here are part of the solution. The second part of our solution, we can include 2 because of the solid circle, and it goes all the way up to infinity, which we always end with a soft bracket. Let's practice another one. So this one contains several fractions, so the first thing I'm going to do, as always, is get rid of the fractions. I'm going to take the first equation and multiply both sides by 3. I'll add 12 to both sides. And then divide both sides by 2. Next, I'm going to multiply both sides by 4. I'll subtract 8 from both sides. And I get x is greater than or equal to negative 12. So I will start writing some numbers up here. Let's see here, I might have to be creative. Lengthen this a little bit. So let's graph our first one, and we can be approximate. This number line isn't fantastic. Let's say that this is about 10.5. X can be less than or equal to. X can be greater than or equal to negative 12. So what is all colored on this number line? What contains markings? Everything does. Therefore, we have a solution that goes from negative infinity all the way up to positive infinity. So all real numbers are solutions to this compound inequality.